There is a moment that comes every night without fail when the world begins to grow quiet. It doesn't happen all at once. It's gradual, gentle. The way the last light fades from the sky after the sun has gone down, not a single moment of darkness, but a slow, unhurried dimming until everything is still. The sounds of the day, the things you carried with you through the hours, the noise and the movement and the weight of all the small decisions, they begin to fall away, one by one, slowly. The way leaves fall from a tree in autumn, drifting down without effort, without urgency, without needing to be anywhere at all. And as those sounds fade, as the day releases its hold on you, something else comes in to take their place. Quiet. A deep, soft, patient quiet that has always been there, waiting just beneath the surface of the day, waiting for this moment when you finally stop moving and let yourself be still. You are still now. You are here, in the dark, in the quiet, and there is nowhere else you need to be. Nothing you need to do, nothing waiting for your attention, just this. Just the slow, easy rise and fall of your breathing, just the weight of your body, heavy and comfortable, just the soft, familiar dark. Take a breath, let it out slowly, all the way to the end, and let your shoulders drop, just a little. There you are. On a night like this, if you were somewhere far from the city, far from the lights that we have built to push the darkness back, if you were somewhere quiet, somewhere open, somewhere where the sky goes all the way down to the horizon in every direction, you could look up, and if you looked up, and if your eyes had time to adjust, to let the dark in slowly, the way the dark likes to be let in, you would begin to see something. At first, just stars. More stars than you can count, more stars than you usually see there in the city or the town, where the glow of streetlights and windows washes out the faintest ones and leaves you with only the brightest handful. But here, away from all of that, the stars come back, the ones that are always there but that you usually can't see. They appear slowly, one by one, and then in clusters, like something being revealed rather than something being added. And then, as your eyes keep adjusting, as the dark becomes more familiar and less frightening, you begin to notice something else. A kind of glow, not a sharp light, not a bright light, something softer than that. A faint, diffuse luminescence stretched across the sky from one side to the other, like something spilled across the darkness in a long, slow arc, like the memory of a river made of light, suspended above you in the night. You might blink, you might think you've imagined it, but it's there. It's always been there. We call it the Milky Way. People have been looking up at that soft river of light for as long as there have been people who look up. Every culture, every civilization, every generation of human beings who lived before electric light made the night sky invisible. They all knew it. They all lay on their backs in the dark and looked up at it and felt something. Some called it a river. Some called it a road. Some said it was the path of souls traveling to the next world, a bridge between here and somewhere else, a seam in the fabric of the night. Some thought the gods had spilled milk across the sky, and that is where our name for it comes from in the end, the Milky Way, the galaxy, from the Greek word for milk. But we know now what it actually is. It is us, That faint river of light, that soft, pale glow stretched across the sky, is the combined light of hundreds of billions of stars, stars so distant that we cannot see them individually, stars so numerous that their light blurs together into a single, continuous band of gentle luminosity. We are not looking at something outside of us when we look at the Milky Way. We are looking at our home. We are inside it. We are part of it. The earth and the sun and everything we have ever known or touched or imagined, all of it exists within that faint and beautiful river of stars. And tonight, slowly, gently, without any rush at all, we are going to travel through it. There is no hurry. This is important to remember. There is no destination we are trying to reach tonight, no information you need to hold on to or remember in the morning. We are simply going to drift, the way you drift on the edge of sleep through the vast, quiet, beautiful spaces of our galaxy. We are going to let the universe be exactly as large as it is. We are going to let the distances be exactly as incomprehensible as they are, and we are going to find, somewhere in all of that vastness, a kind of peace. The peace that comes from being very small in a very large and very beautiful place. The peace that comes from remembering that most of the universe, most of existence, is simply dark and quiet and still, like this room, like this moment, like you, right now, breathing softly in the dark. Your body is growing heavier, just a little, with each breath. Your thoughts are growing quieter, just a little, with each passing moment. Let them. Let the quiet come. We have a long and gentle journey ahead of us, and there is all the time in the universe. The Milky Way is, by any measure, we have incomprehensibly large. But let's not start with numbers. Not yet. Numbers have a way of sliding past the mind without landing, especially at this hour, especially when the mind is beginning its slow and beautiful descent towards sleep. Instead, let's start with a feeling. The feeling of looking up at the night sky and understanding, not just knowing, but understanding in your chest, in your body, that the stars you're seeing are not decorations. They are not painted on the inside of a dome. They are not close. Each one is a sun. Each one is an enormous ball of burning gas, most of them far larger than our own sun, all of them consuming themselves in a slow nuclear fire that has been burning for millions or billions of years. Each one is so hot and so bright that if you were to stand on a world orbiting it, its light would warm your face the way our sun warms ours, and most of them, the astronomers now believe, have planets, worlds orbiting those distant suns, some rocky and small like our own, some enormous and gaseous like Jupiter or Saturn, some perhaps covered entirely in ocean, some perhaps in the dim, early stages of developing the chemistry that, over billions of years, sometimes becomes life. We don't know. We may never know. But the possibility, the sheer, staggering, almost unbearable possibility of it, is worth holding gently for a moment as you rest here, in the dark. All those lights in the sky, all those suns, and around them, perhaps, worlds. Before we begin our journey, before we drift outward into the wider reaches of the galaxy, it helps to know where we are standing, or rather, where we are floating, because that is what we are doing, after all. We are not standing still. We are never standing still. Even now, as you lie perfectly motionless in the dark, You are moving. The Earth is rotating on its axis, carrying you eastward at roughly 1,000 miles per hour, depending on how close you are to the equator. The Earth is also orbiting the Sun, moving at about 67,000 miles per hour along a path that takes a full year to complete. And the Sun itself, along with the Earth and all the other planets, is orbiting the center of the Milky Way. At about 500,000 miles per hour, you are right now hurtling through space at 500,000 miles per hour. And yet, you feel perfectly still. You feel the weight of your body against the mattress, the slow movement of your breath, the small, familiar sounds of the room around you, and nothing of the motion, none of the speed, not even a whisper of it. This is one of the strange and beautiful things about moving in space, when everything around you is moving together. When there is no fixed point to measure yourself against, the motion becomes invisible. It becomes stillness. It becomes exactly this: you, quiet in the dark, going nowhere and everywhere at once. Our address in the galaxy. If we were to write it out the way you'd write an address on an envelope, would go something like this: the third planet from the Sun, the solar system, the Orion Arm, the Milky Way galaxy. The Orion Arm, that is the name of the particular region of the Milky Way where our Sun makes its home. It is one of the galaxy's several spiral arms, long, curving streams of stars and gas and dust that sweep outward from the dense, bright center of the galaxy, like the arms of a pinwheel turning in the wind. Our arm is sometimes called a spur, a minor branch, not one of the major arms, but a smaller structure curving off a larger one. In the grand architecture of the Milky Way, we live on a side street, and there is something quietly lovely about that. We are not at the center of things where the stars crowd close together and the energy is intense and the radiation fierce. We are not at the sparse outer edges where the stars thin out and the dark between them deepens and the galaxy grows quiet and diffuse. We are somewhere in the middle distances, in a region that is, cosmically speaking, calm and well suited to the patient work of building planets and evolving life. The suburbs of the galaxy, quiet, stable, far from the noise at the center. Our Sun, that faithful yellow-white star that rises and sets with such perfect regularity that we have built our entire sense of time around it, has been making its slow orbit of the galactic center for about 4.5 billion years. It takes approximately 230 million years to complete one full orbit. Think about that for a moment if you like, or simply let it drift past you like a cloud. It doesn't need to be grasped. 230 million years for one trip around the galaxy. In the time it takes the Sun to complete a single orbit, entire mountain ranges rise and erode and disappear. Continents drift across the surface of the Earth, colliding and separating, rearranging themselves into configurations we would not recognize. Species evolve and flourish and go extinct, sometimes in great catastrophic waves, sometimes slowly and quietly, one by one. The Sun has completed approximately 20 of these orbits since it was born. 20 slow, enormous loops around the galaxy, and on this particular night, in this particular moment of the Sun's long journey, you are here, resting in the dark, part of it, a temporary arrangement of atoms that the galaxy has assembled briefly into something that breathes and dreams and wonders. 230 million years is the length of one galactic year, and our Sun, at 4.5 billion years old, is roughly 20 galactic years old. 20. There is a gentleness to that number somehow, young enough to still have most of its life ahead of it, old enough to be settled and steady and sure of itself. Our Sun is middle-aged in stellar terms. It has used about half the hydrogen fuel in its core. It has another 5 billion years of steady, reliable burning ahead of it. 5 billion years of sunrises, 5 billion years of light falling on water and warming stone and keeping the chemistry of life moving forward. That is a very long time to be safe. You are safe right now, under the light of a star with 5 billion years left to burn. Let that settle into you. The warmth you feel on a sunny afternoon, the light that comes through windows and makes dust motes visible in the air. That is the product of something ancient and stable and enduring beyond all ordinary imagination. You are held tonight in the warmth of a star that will still be burning long after every human memory of this moment has dissolved. There is a peace in that, if you let yourself feel it. From the perspective of the galaxy, our Sun is not a remarkable star. It is average in its mass, average in its brightness, average in its temperature, average in its age. It sits squarely in the middle of the distribution of stellar types, not one of the giants, blazing blue-white with ferocious intensity, not one of the tiny red dwarfs, barely glowing, slow and ancient and patient, just average. And this averageness, this perfectly unremarkable, perfectly ordinary nature, may be one of the most important things about it, because life, it seems, needs time. It needs billions of years of patience and stability. It needs a star that burns steadily and reliably, without dramatic fluctuations, without sudden outbursts of energy, that would strip a planet's atmosphere and start the chemistry of life over from scratch. The most brilliant stars burn out too fast. The longest-lived stars burn too cool. But a star like our Sun, steady and warm for 10 billion years, gives the chemistry of life exactly the time it needs. Our Sun's ordinariness may be the reason you exist, the reason you are here, right now, breathing softly in the dark, listening to the story of the galaxy that made you. Imagine for a moment that you could rise, not quickly, not dramatically, just slowly, gently, lifting away from the earth the way a balloon drifts upward on a still day, higher and higher, until the details of the ground below you blur into shapes, and the shapes blur into patterns, and the patterns become the curved blue edge of the earth against the black of space, and then higher still, past the moon, cold and grey and quietly beautiful in the dark, past the inner planets, Venus gleaming white, wrapped in its thick, hot clouds, Mercury, small and scarred, orbiting close to the Sun with patient regularity. Higher, further, out past the orbit of the Earth, out past Mars with its ancient red dust and its long extinct volcanoes, out through the asteroid belt where 1 billion pieces of rock and ice drift in silent, unhurried orbits, out past Jupiter, enormous, banded, its storms turning in slow spirals across its face, past Saturn with those extraordinary rings, that flat, perfect geometry of ice and rock, pale gold in the distant sunlight, further, past the cold blue worlds of the outer solar system, past Uranus and Neptune, and the scattered objects of the Kuiper belt, growing dimmer and more distant with every passing moment, and then the solar system falls away behind you, and you are in the space between stars. The space between stars is very large. That might sound obvious, but it is the kind of obvious thing that, when you really sit with it, when you really let yourself feel the scale of it, becomes something else entirely, something closer to wonder. The nearest star to our Sun is called Proxima Centauri. It is approximately 4¼ light years away. A light year is the distance that light travels in 1 year, moving at nearly 300,000 kilometers per second. Light crosses the distance between the Earth and the Moon in about 1¼ seconds. It crosses the distance between the Earth and the Sun in about 8 minutes. And it takes 4¼ years to reach the next star. 4 years of travelling at the speed of light, and you would still be in what might reasonably be called the neighbourhood. The stars are islands in an ocean of nothing, separated by distances so vast that the fastest thing in the universe takes years to cross between them, and you are drifting through that ocean now, slowly and safely, watching the lights of the stars recede and grow and shift around you as you rise. Higher still, and the stars begin to resolve into a pattern from far enough above the plane of the Milky Way, from a vantage point high enough and distant enough, you would begin to see the shape of it. A spiral. Not a perfect spiral, not the clean, mathematical lines of a diagram in a textbook, something more alive than that, something that looks less like a drawing and more like something that grew, like a slow, enormous flower of light, its petals curving outward from a bright and densely packed centre. 4 main arms curving away from the core, each one a long curving river of stars and gas and dust, sweeping outward and trailing behind the rotation of the galaxy, like the wake of something immense moving slowly through deep water. Between the arms, quieter spaces, not empty, never truly empty, but less dense, less bright. The spaces between the rivers of stars, and somewhere in one of those quieter spaces, in a modest spur branching off one of the smaller arms, a single pale star, too small to see from this distance, with its family of 8 planets arranged around it in their patient, invisible orbits. Our Sun, our home. From here, it is invisible. From here, we are nothing, a footnote in the biography of a galaxy, and somehow that is comforting. The spiral arms of the Milky Way are not fixed structures, they are not like the spokes of a wheel, rigid and unchanging, they are more like waves. Think of the way a wave moves across water. The wave has a shape, it has a crest and a trough. It moves across the surface of the ocean, but the water itself, the actual molecules of water, do not travel with the wave. They move up and down as the wave passes through them, and then settle back to where they were. The spiral arms are something like this. They are regions of slightly higher density, a kind of wave moving through the disk of the galaxy, and the stars drift in and out of the arms as they make their long orbits around the galactic center. A star might spend tens of millions of years drifting through the brighter, denser regions of a spiral arm, and then drift out into the quieter spaces between the arms and then back in again on the next pass. Our Sun is currently moving through the Orion Arm. In the future, in the incomprehensibly distant future, it will drift out of it, into the quieter space between arms, and perhaps, eventually, into one of the major arms, but not for a very long time. For now, we are here, in this particular arm, in this particular moment of the galaxy's slow rotation, held in place by gravity, moving without effort, going around and around the great slow wheel of the Milky Way, as we have been doing for 4.5 billion years. The Milky Way rotates, but not the way a solid object rotates. When a wheel spins, every part of it completes one rotation in the same amount of time. But the Milky Way is not rigid. It is made of gas and stars and dust and dark matter, each component free to move at its own speed, following its own gravitational orbit. And because of this, the inner regions of the galaxy rotate faster than the outer regions. Stars close to the galactic center complete their orbits in millions of years. Stars out where our sun lives take hundreds of millions of years. Stars at the outermost edges take longer still. The galaxy is winding, its inner parts racing ahead of its outer parts. And it has been doing this since it formed, nearly 14 billion years ago. This differential rotation is part of what creates and maintains the spiral structure. The inner stars pulling ahead, the outer stars lagging behind, the whole disk developing those long, trailing, beautiful arms. A galaxy is, in a sense, always in the process of becoming itself, always winding, always shifting, always slowly rearranging its light and its darkness into new configurations, just as you, in your own slow way, are always in the process of becoming yourself, and just as you, right now, are still, resting in the quiet, letting the winding continue without your attention, deep in the spiral arms, in the thickest, most crowded regions of gas and dust, there are clouds. Not clouds like the ones in our sky, not the white, drifting, water vapor clouds that catch the light of the setting sun and turn pink and gold above the horizon. These are something altogether different. These are enormous, ancient, cold. They are called molecular clouds, and a single one of them can contain enough material to make 1,000,000 stars. They are dark. When you look at a photograph of the night sky and you see a region that seems strangely empty, a place where the stars thin out and disappear behind what looks like a void, that is often not a void at all. That is a molecular cloud blocking the light of the stars behind it, a cloud so thick with gas and dust that no visible light can pass through it. From the outside, they look like holes in the universe. From the inside, they are nurseries. Within these vast, dark, cold clouds, something is happening, something slow, something patient, something that cannot be hurried. Gravity is working. The cloud is not perfectly uniform. It has regions of slightly higher density, places where a few extra molecules have drifted together and accumulated, the way sediment accumulates at the bottom of a river. And those slightly denser regions, because they have slightly more mass, exert slightly more gravitational pull on the material around them, and so they grow, slowly, over millions of years, drawing in more gas, more dust, becoming denser, pulling harder, drawing in more still, like a slow, cold, invisible breath being drawn inward. As the gas accumulates and compresses, it begins to heat up, and at the center of the collapsing cloud, in the densest, hottest region, a protostar begins to form. A protostar, a star that doesn't yet exist, but that is becoming. The protostar glows, not yet with the fierce, steady light of a true star, but with the warmth of compression, with the faint infrared glow of something heating up in the dark. Hidden inside its thick cocoon of gas and dust, invisible to ordinary telescopes, it quietly accumulates mass. More gas falls inward. The protostar spins faster as it grows. The collapsing cloud flattens into a disk, a swirling, rotating disk of gas and dust around the young protostar, like water spiraling toward a drain. This disk is where planets will eventually form, but not yet. For now, the protostar is still growing, still accumulating, still heating up. The temperature at its center is climbing 10,000 degrees, 100,000, a million, and then, at some threshold, at some temperature that the universe has set as its requirement for this particular transformation, something ignites. Nuclear fusion begins, hydrogen atoms in the core, moving so fast, under such enormous pressure, at such extraordinary temperatures, begin to collide and fuse together to form helium. And in that fusion, in that joining, a tiny amount of mass is converted into an enormous amount of energy. The star wakes up. When a star ignites, the energy released pushes outward against the weight of all the gas that has been pressing inward. A kind of equilibrium is established. Gravity pulling in, energy pushing out. The two forces balanced against each other in a relationship that can last for billions of years. This is a star, not a burning object, in the way that a fire burns, not a chemical reaction consuming fuel and producing light and heat as a byproduct, but a nuclear furnace, a place where the fundamental forces of the universe are held in precise and delicate balance, where matter is converted into energy at a rate just fast enough to hold everything together, and where that energy radiates outward in all directions as light and heat and warmth. A star is, in a sense, a controlled explosion that lasts for billions of years, and when a star is born, its light finally pushes through the cloud of gas and dust that surrounded the protostar, and a new light appears in the galaxy. One more point in the great river of stars, one more small flame in the dark. The most famous stellar nursery that we can see from Earth, and one of the most beautiful things in the sky, is the Orion Nebula. You may have seen it on a clear winter night in the northern hemisphere if you find the constellation Orion. The three bright stars of his belt lined up in a short, neat row, and look below them at the region of sky that represents his sword, you will see a faint, fuzzy patch of light. That fuzzy patch is the Orion Nebula. It is a cloud of glowing gas, approximately 40 light-years across, illuminated from within by the fierce ultraviolet light of young, hot stars that have recently formed inside it. The gas glows in shades of rose and gold and pale blue, sculpted by stellar winds into shapes of extraordinary beauty. Towers of gas and dust, hundreds of light-years tall, delicate, wispy filaments, dense, dark globules where new stars may be forming even now. If you were to drift slowly through the Orion Nebula, travelling at some impossibly fast speed that still took thousands of years to cross its 40 light-year breadth, you would see around many of the young stars flat disks of gas and dust. The early stages of planetary systems, dust grains sticking together to form pebbles, pebbles accumulating into larger rocks, rocks colliding and merging into the early embryos of worlds. In the glowing heart of the Orion Nebula, planets are being born right now. New worlds accumulating out of ancient stardust in a cloud of light 40 light years wide. And none of it in any hurry. The stars that form in these nurseries are not all the same. The mass of the collapsing gas cloud that forms a star, how much material falls together, determines almost everything about it. A very massive star, 10 times, 20 times, 50 times the mass of our sun, burns ferociously bright. Blue-white and fierce, it pours out energy at a rate that would overwhelm anything nearby. These stars are spectacular. They illuminate the nebulae around them with dazzling light, but they are brief. A star 50 times the mass of the sun might burn for only a few million years before exhausting its fuel. In the time scale of the galaxy, a few million years is barely a moment. And then there are the smallest stars, red dwarfs, dim and cool and deep red. They burn so slowly, so efficiently, so gently, that some of them will still be shining long after the universe itself has grown cold and dark. The smallest red dwarfs are expected to have lifespans measured in trillions of years, not billions, trillions. A star that will still be burning 100 times longer than the current age of the universe. What patience, what extraordinary, quiet, unhurried patience, and between the fierce, brief giants and the dim, ancient dwarfs, stars like our sun, warm and steady, not too bright, not too dim, not too brief, not too endless, burning for 10 billion years at a pace and temperature that on the one planet we know about was just right for the slow, patient emergence of life, just right for us. Every star follows a story, not the same story. Every star's story is its own, shaped by its mass and its age and the company it keeps and the region of the galaxy in which it finds itself. But every story has the same broad shape, a beginning in the dark, in the cold, in the slow gathering of gas, a long burning middle, and an ending. Every star ends, and every ending, in its own way, is a kind of gift. Our sun, right now, at this moment, as you lie still in the dark, is fusing hydrogen into helium in its core. This process has been happening for 4.5 billion years and will continue for another 5 billion years. The energy released by this fusion takes a very long time to reach the surface of the sun. The energy generated in the sun's core, in the form of photons of light, begins an extraordinarily long and wandering journey outward through the dense, hot interior of the sun. At every step, the photons are absorbed and re-emitted by the particles around them, changing direction, bouncing off in new trajectories, working their way outward in a slow, random walk through the solar interior. This journey takes, on average, somewhere between 10,000 and 100,000 years. The light that warms your face on a sunny afternoon. The light that comes through windows and casts shadows and makes the day bright was generated in the core of the sun somewhere between 10,000 and 100,000 years ago, when that light was born deep in the sun's core. Human beings were living in the Ice Age, painting on cave walls, making their slow, patient way across the continents, following the animals, following the seasons, looking up at the same stars you can see tonight. In 5 billion years, the hydrogen in the sun's core will begin to run low. When that happens, the core will contract. The outer layers will expand. Slowly, over millions of years, The sun will swell outward into something called a red giant. Its surface temperature will cool as it expands, shifting from yellow-white to orange to a deep, burning red. And its size will reach outward past the orbit of Mercury, past the orbit of Venus, and perhaps to the orbit of the Earth itself. But let's not stay there. 5 billion years is such an incomprehensible distance that it carries no weight tonight. It is a curiosity, an interesting footnote, not a source of worry. Tonight, the sun is steady. Tonight, the light coming through your window tomorrow morning will be warm and gentle and familiar. Tonight, the Earth is exactly where it has been for 4.5 billion years, and will be for billions more. You are safe in the light of a middle-aged star. After the red giant phase, our sun will do something beautiful. It will shed its outer layers, not explosively, not violently. It will simply breathe them out. Over thousands of years, the outer layers of the sun will drift gently outward into space, expanding slowly, illuminated from within by the hot, dense core they're leaving behind. This expanding shell of glowing gas is called a planetary nebula, and they are extraordinary. The Helix Nebula, sometimes called the Eye of God, is one such object, a vast, glowing ring of expelled gas, roughly 650 light-years away, its edge lit up in shades of deep red and gold and blue-white. At its center, a tiny point of fierce white light, the remnant of the star after its outer layers have gone. That point of white light is a white dwarf, the compressed core of a star, roughly the size of the Earth, but containing as much mass as the sun. A white dwarf is not generating energy through fusion, it is simply cooling, radiating away the heat accumulated over its long life as a star, growing dimmer and cooler over billions of years, a slow, patient fading. And its atoms, the atoms that burned in its core for 10 billion years, will have been scattered across space by its planetary nebula, drifting through the galaxy, joining new clouds, perhaps one day becoming part of new stars, new worlds, new oceans. The material does not end, it returns, it is remade. For stars much more massive than our sun, the ending is different. When a star 10 or 20 or 50 times the mass of the sun exhausts the fuel in its core, the core collapses catastrophically in a fraction of a second. The outer layers of the star, which were falling inward as the core collapsed, hit the suddenly rigid, compressed core and are hurled outward in an explosion of almost unimaginable violence, a supernova. For a brief moment, for a few weeks or months, a supernova can outshine an entire galaxy, billions of stars, in a single star's death. The night sky, if it happened close enough, would be bright enough to cast shadows. And then the light fades, and what remains, in the quiet, after the storm, is either a neutron star or, if the original star was massive enough, something stranger still, a black hole, at the center of the Milky Way. 27,000 light-years from where our sun burns quietly in its corner of the Orion Arm, there is something hidden. Light, traveling at 300,000 kilometers per second, takes 27,000 years to make the journey from the galactic center to our sun. The light leaving the galactic center right now, the light that is currently making its way through the dark at the speed of light toward us, will not reach us for 27,000 years. The galactic center is hidden from us in both space and time. It is also hidden from our eyes by the gas and dust between here and there. Thick, obscuring material that absorbs and scatters visible light the way fog scatters the beam of a headlight. But other wavelengths of light, radio waves, infrared, X-rays, pass through the dust more easily. And when astronomers turn these instruments toward the galactic center, what they see is extraordinary. The galactic center is a place of tremendous density and activity. Stars are packed together there 10,000 times more closely than in our quiet neighborhood. And at the very heart of all of this, at the center of the center, something immense is waiting. We call it Sagittarius A star. It is a supermassive black hole, a region of space where gravity is so intense that nothing, not matter, not light, not any signal or information of any kind, can escape from within its event horizon. No light escapes, which means that a black hole itself is, by definition, invisible. What we can see is the effect of a black hole on the material around it. Surrounding Sagittarius A star is a region of extremely high stellar density. Stars orbiting the black hole at tremendous speeds, some completing full orbits in just a few years, moving so fast that the only thing that could explain their orbits is an object of enormous mass concentrated in a very small space. By watching those stars for decades, tracking their orbits year by year with increasingly powerful telescopes, astronomers have mapped the presence and the mass of Sagittarius A star with remarkable precision. 4 million times the mass of the Sun. 4 million suns worth of mass, compressed into a region smaller than the orbit of Mercury around our Sun. In 2022, astronomers produced the first direct image of Sagittarius A star, not the black hole itself, which by definition emits no light, but the ring of superheated gas swirling around the black hole's event horizon, glowing bright and fierce and orange gold, and at the center of that glowing ring, a shadow, the shadow of a black hole, a dark circle in the middle of a circle of light, at the center of our galaxy, 27,000 light years away. When the image was released, scientists who had spent decades working on the project described the moment of first seeing it as deeply moving. Not because it was frightening, but because it was real. After all the mathematics and all the models and all the decades of indirect evidence, there it was, a photograph, a picture of something at the center of the galaxy we were born in, a picture of the heart of our home. Sagittarius A star is, by the standards of supermassive black holes, quiet, dormant, calm, consuming very little, sitting at the center of things like a sleeping giant, present, immense, but still. The center of our galaxy is at rest, and so, tonight, are you. Above and below the flat disk of the Milky Way, scattered through the vast spherical region that surrounds the galaxy like a halo, there are nearly 200 globular clusters. They orbit the Milky Way on long, sweeping paths that carry them high above the disk and then back down through it and out below it on the other side, taking hundreds of millions of years to complete a single orbit. Patient, ancient things, following their orbits the way they have been following them since the galaxy itself was young. A globular cluster is a spherical collection of stars, tightly packed, at the center, thinning toward the edges, held together by gravity into a compact, glittering sphere. Some contain tens of thousands of stars, some contain millions, and all of them are old. The stars in the oldest globular clusters formed within the first billion years of the universe's existence. They were burning, steadily, quietly, in their tightly packed spheres before our galaxy had fully formed, before the sun existed, before the solar system existed, before the Earth existed. When you look at a globular cluster, you are looking at some of the oldest light in the galaxy. You are looking at things that were already old when everything around them was young. And then there is the invisible, the thing we cannot see, the thing that is, nonetheless, everywhere. Dark matter. It does not interact with light, it does not emit light, absorb light, or reflect light. It passes through ordinary matter without leaving a mark, and yet it is everywhere. We know it is there because of how the galaxy moves. When astronomers measured the orbital speeds of stars at different distances from the galactic center, they expected to find a particular pattern. Stars far from the center, where the visible mass thins out, should orbit more slowly. But the stars at the outer edges of the Milky Way are moving too fast, as though there is much more mass than we can see pulling on them, as though the visible galaxy is embedded in a much larger, invisible structure, a halo of dark matter surrounding the visible galaxy like a great, unseen embrace. 5 times as much dark matter, by mass, as all the visible matter in the galaxy combined. We are held together by something we cannot see. The galaxy is held together by something we do not understand. And somehow, tonight, that feels less frightening than it might, and more like something else, something like comfort, being held without knowing what is holding you is still being held. The Milky Way does not travel alone through the universe. Around it, held close by gravity, orbiting in great, sweeping paths, there is a family of smaller galaxies, satellite galaxies, dozens of them, ranging from fairly substantial to so small and diffuse that they were only discovered in recent decades as telescopes grew more sensitive. The most famous members of this family are 2 that can be seen from the southern hemisphere on a clear night with the naked eye: the Large Magellanic Cloud and the Small Magellanic Cloud. They appear as detached pieces of the Milky Way, 2 bright, irregular patches of light in the southern sky, hovering at the edge of visibility like soft, luminous clouds that forgot to join the rest of the sky. The Large Magellanic Cloud is about 160,000 light-years away. It contains something like 30 billion stars. It is irregular in shape, actively forming new stars at a vigorous rate. Both Magellanic Clouds are being slowly, gently drawn in by the gravity of the Milky Way. As they orbit our galaxy, as they make their long, sweeping passes, the Milky Way's tidal gravity pulls on them. It stretches them. It draws out long streamers of gas and stars into a ribbon called the Magellanic Stream, a trail stretching across 140 degrees of sky over billions of years. The clouds will be gradually incorporated into the Milky Way. Their stars will become Milky Way stars. Their gas will feed new generations of stars. The boundary between them and us will dissolve, slowly, over billions of years, until there is no longer any meaningful distinction. But for now, they remain distinct. 2 small galaxies keeping their own company, following their long orbit of the larger galaxy, that is, gradually drawing them home. 2.5 million light years away from us, there is another galaxy. You can see it with the naked eye on a clear, dark autumn night in the northern hemisphere. It appears as a faint, soft, oval smudge of light in the constellation Andromeda. Easy to miss, easy to dismiss as a cloud, a trick of the eye. But it is not a cloud, it is the Andromeda galaxy, a spiral galaxy much like our own, containing perhaps 1 trillion stars, with its own spiral arms and its own central bulge and its own family of satellite galaxies orbiting around it. When you look at the Andromeda galaxy with the naked eye, you are seeing light that left its source 2.5 million years ago. 2.5 million years ago, the earliest members of the genus Homo were making their way across the African landscape. The light you are seeing tonight has been traveling through space since before our genus existed. The Andromeda galaxy is approaching us. At approximately 110 kilometers per second, it is moving toward the Milky Way. In approximately 4 to 5 billion years, the Andromeda galaxy and the Milky Way will begin to interact. Their outer regions will overlap, their spiral arms will pass through each other, stars will be flung into new orbits, the spiral arms of both galaxies will be torn apart, stretched into long, curving tidal tails of stars and gas. And gradually, over hundreds of millions of years, they will merge into a single, larger galaxy. The stars will survive. Our sun, if it still exists, will find itself in a new orbit in a new galaxy. The night sky will look unrecognizable. New constellations will trace new patterns, but there will still be stars. There will still be light, and perhaps there will still be someone, something, looking up at it. There is something both humbling and strangely freeing about knowing that the galaxy we live in is not permanent, that the beautiful spiral structure, the arms of stars, the glowing core, the quiet suburbs where our sun burns, are temporary configurations, patterns in an ongoing process. The Milky Way is not a thing, it is an event, a slow, billions of years long event made of the motion of stars and gas and dark matter, following the laws of gravity with perfect mathematical fidelity. And right now, tonight, we are in the middle of it, in the calm middle of an event that began over 13 billion years ago and will not end for billions more. And you are here in it, breathing, resting, held by the same gravity that is drawing Andromeda slowly toward us across 2.5 million light years of space. Let's come back, now, to something closer, something much closer than the galactic center, or the Magellanic Clouds, or the approaching light of Andromeda. Let's come back to you, to this body, resting in the dark. This particular arrangement of matter, breathing slowly, growing heavier with each breath, settling deeper into the quiet. Let's talk about what you are actually made of. Your body contains roughly 7 billion atoms. A 7 followed by 27 zeros. More atoms in your body than there are stars in the observable universe, and every single one of those atoms has a history. Not a recent history, a deeper history. A history that stretches back billions of years to the hearts of stars that lived and died long before the Earth was born. The oxygen atoms in your lungs right now, the carbon atoms in your cells, the calcium in your bones, the iron in your blood. None of them were made on Earth. None of them were made by the sun. They were made in stars. The very lightest elements, hydrogen and helium were made in the first few minutes after the Big Bang. In the earliest moments of the universe, before stars existed, before galaxies existed, when the universe was a hot, dense, rapidly expanding plasma. The temperatures and pressures were high enough to fuse the first simple atomic nuclei. Those hydrogen and helium nuclei, made in the first 3 minutes of the universe's existence, became the raw material of the first stars. And the first stars took that hydrogen and helium and turned it into heavier elements: carbon, oxygen, nitrogen, the elements of life. When those first stars died, in supernovae of extraordinary violence, they scattered those elements into the young universe, and so it has continued, generation after generation of stars, each generation forming from the enriched remnants of the last, each generation forging heavier and heavier elements in its core, each generation, in dying, returning those elements to the interstellar medium. The iron in your blood was forged in the core of a star that died in a supernova explosion before the Earth existed. The oxygen in your lungs was made inside a star that burned billions of years ago. The carbon in every cell of your body was assembled, atom by atom, in stellar cores and scattered into space by stellar winds and supernovae over billions of years. You are the universe, assembled. You are the galaxy, concentrated. You are the product of 14 billion years of cosmic chemistry slowly working its way towards something more complex, something more aware, something that can lie in the dark at night and think about where it came from. The galaxy, in making you, made itself a witness. You are how the Milky Way knows it exists. Think about the hydrogen atoms in your body. Some of them, the oldest ones, have been part of the universe since the very beginning. Formed in the Big Bang, they have drifted through space as part of vast interstellar clouds. They have fallen into stars and been fused into heavier elements. They have been ejected back into space in stellar winds. They have floated through the dark for millions of years before finding their way into a new cloud, a new star, a new planet. They have been part of oceans, part of rain, part of living things billions of years before you, and now they are part of you. The water in your body, the hydrogen in that water, carries a history longer than the earth, a history longer than the sun, a history that stretches back to the first moments of the universe. You contain in your cells and tissues and blood the oldest things in existence. You are a temporary arrangement, beautiful and improbable and temporary. And right now, you are resting. There is a kind of quiet that exists in deep space that has no equivalent on Earth. On Earth, even in the most remote and silent places, there is sound, wind, the movement of air, the creak and shift of the world around you, the sound of your own breathing, your own heartbeat. In space, there is no air to carry sound. The space between stars is, in the truest sense, silent, not just quiet, not just hushed, silent in a way that nothing on earth can be silent. A silence so absolute and so vast that it is less like the absence of sound and more like another kind of presence. And most of the universe, most of the Milky Way, most of the space we have been drifting through tonight is this silent. The Milky Way, for all its 200 billion stars, is mostly empty. The stars are islands, separated by light years of almost nothing. If you were to shrink our sun down to the size of a marble, a small, round marble, about a centimetre across. The nearest star, Proxima Centauri, would be another marble sitting approximately 280 kilometres away. 280 kilometres of empty space between two marbles, and between those marbles, nothing, or almost nothing. A few atoms of hydrogen per cubic centimetre, a few particles of dust. The universe is, overwhelmingly, nothing. And somehow, this is not a sad thing. The notes in music matter, but so do the silences between them. A piece of music with no silence, no pause, no breath between the sounds would not be music. It would be noise. The stars in the galaxy matter, but so does the space between them. The dark, quiet, cold, vast, silent space between them is not the absence of the galaxy. It is part of the galaxy. It is most of the galaxy. And you, right now, in the space between your thoughts, in the quiet between one breath and the next, you are participating in something like this. The spaces in you are not deficiencies, they are part of the structure. Rest in them. It is time to come back. Not because there is anything wrong with being out here, drifting through the quiet spaces of the galaxy, letting the stars drift past, but because your body is here, in this room, in this bed, in this particular night, and it is ready now for sleep. So, let's drift back, slowly, without rushing, the way you would float back to shore on a calm day when the tide is turning gently in your direction, from our vantage point above the galactic plane, from wherever we have been drifting out among the stars and the dark matter and the ancient light, we begin to move inward, back toward the Orion Arm. The galaxy turns slowly beneath us as we descend. The spiral arms, those long curving rivers of stars, sweep past in the great slow rotation. The centre glows, distant and dense, Sagittarius A star sitting quiet and enormous at its heart. Back into the Orion Arm now, the star density increasing around us as we move into the brighter, richer regions of the spiral structure. Back toward our neighbourhood, the quiet suburban stretch of the Orion Spur where our sun has been burning for 4.5 billion years. And there, ahead of us, a small yellow-white star, ordinary, average, steady, faithful, our sun. Back into the solar system now, the outer planets appearing one by one in the dark. Neptune, far and cold and blue, its winds the fastest in the solar system, its moons icy and strange and beautiful in their own quiet way. Uranus tilted on its side, rolling along in its orbit, its pale blue-green surface serene and cold. Saturn, and those rings. There is nothing quite like Saturn's rings. From a distance, they look like a solid disk, but up close, they are made of individual particles, billions and billions of particles of ice and rock, ranging in size from tiny grains to boulders the size of houses, each one following its own orbit around Saturn, the whole system arranged in that extraordinary, precise, flat geometry that from a distance looks so impossibly neat. The rings are lit by the distant sun, and they glow, pale gold and white and grey. Saturn is one of the most beautiful things in the solar system. Jupiter next, enormous, banded, its atmosphere a swirling tapestry of orange and white and gold, its great red spot turning slowly in the southern hemisphere. Past the asteroid belt, a ring of rocky debris between Mars and Jupiter, fragments of material that never quite managed to assemble itself into a planet. Past Mars, red and quiet, its sky a pale butterscotch, its surface cold and thin-aired, and ancient, and then, ahead of us, growing slowly larger as we approach the most familiar sight in the solar system, the Earth. From space, the Earth is extraordinary. The depth of the blue of the oceans, which is unlike any blue on the surface. The white of the clouds, thick and curling, organized into vast weather systems that span continents. The brown and green and white of the land visible through the gaps. And the darkness around it. The absolute blackness of space surrounding this small, bright, living world, which makes the Earth seem both precious and astonishingly alone. There is nothing else like it anywhere in the solar system, possibly anywhere for quite some distance beyond it. A planet with liquid water on its surface, a planet with an atmosphere and weather and oceans and life. So much life, layered and interconnected and ancient and strange. 4 billion years of life woven into the rocks and the soil and the water and the air. A planet where something looked up one night and began to wonder. Back through the atmosphere now, through the thin blue outer edges where the air begins to thicken, through the stratosphere, pale and cold, down into the troposphere, where the clouds drift and the weather happens, over the curve of the horizon, over the dark side of the earth, where city lights make their own constellations on the ground, back over your part of the world, over the country, the city, the neighborhood, down to this building, this room, this bed, this moment. Here you are. You have been away, or perhaps you never left. Perhaps the journey was always interior, a long, slow drift through the spaces of your own imagination, your own capacity for wonder. Perhaps the Milky Way was always here, in this room, in the atoms of your body that were once inside stars. It doesn't matter. You are here now. Your body is here, heavy and warm, breathing slowly in the dark. Your mind is quieter than it was when we began. The thoughts that seemed so present and so urgent earlier in the evening, they have grown small and distant, the way the lights of a city grow small and distant when you rise above it. They will be there in the morning. Everything that needs your attention will be there in the morning, but right now there is only this, the dark, the quiet, the slow, easy rhythm of your breathing, the weight of your body, the 200 billion stars of the Milky Way turning slowly above the cloud cover, invisible but present, as they have been present for every night of your life, as they were present for every night of every life that came before yours, as they will be present for every night that comes after. The galaxy is turning, quietly, slowly, without effort, without sound, at 500,000 miles per hour and completely still. The stars are burning, quietly, steadily, without drama, without interruption, as they have been burning for millions and billions of years. Sagittarius A star is waiting at the center of things, patient, enormous, dark. The globular clusters are circling above and below the plane, making their slow, ancient orbits, the light of their million-year-old stars crossing the dark with perfect indifference to whether anyone is watching. And you are here, small, held, made of stars. Let your body be heavy. Let your thoughts be light. Let the dark be soft and the quiet be deep, and the space between your breaths be as wide and peaceful as the space between the stars. You are in the Milky Way. You are of the Milky Way, and the Milky Way tonight holds you. Drift now, drift, and sleep.